standard series of the wireless communication. I am our instructor Varsha Tak. Let's start our today's lecture series. So at the end of this video, you will be able to learn about the CDMA architecture, that is also known as the Interium Standard 95 architecture. Then we will see the CDMA forward channel, then CDMA reverse channel, and then after we will see the features of the CDMA, and after that we will see the CDMA 2000 architecture. So let's start with the CDMA architecture, that is also known as the Interium Standard 95 architecture. Okay, so here you can see this is the CDMA architecture, or we can say the Interium Standard 95 architecture. Here this abbreviation is written CSS, that means what, the cellular subscriber station, BS that means the base station, MSC that means the mobile switching center, HLR that means the home location register, and EIR that means the equipment identity register, VLR that means the visitor location register, and AC that means the authentication center. So this all terms are there in the architecture. So here you can see the cellular subscriber is there, that with the interface it is connected with the base station. That means we have learned about the air interface. Okay, so it is with the interface it is connected with the base station. Then this base station is connected with the MSC with the air interface. Okay, so mobile switching center that is responsible for routing the calls in the different networks or in the same networks. So architecture is related to same in the GSM that we have learned. Okay, here you can see the MSC is there. So if in the same MSC the data will be transferred, if in the different network, that is the public switch telephone network, so here you can see with the EI interface, MSC is connected with the PSTN, that is the public switch telephone network. Then with the DI interface it is connected with the ISDN, that is integrated service digital network. So when the call is coming from the cellular subscriber, this MSA is responsible for transmitting the call in the same network or in the different network, and it is connected with the different interface. Okay, and here the HLR and VLR, that are the two databases, so in which the information is stored regarding to the mobile station, regarding to the cellular subscriber station. Okay, which type of services is there, okay, then how the call, how the bill will be charged, so that every information that will be stored in the HLR. And VLR gives you the current location of that particular mobile devices. If this device is in the roaming area, so at that time it will send the temporary location to this MSC where this particular device is. Okay, then AC, that is for the authentication center. Okay, authentication center, and EIR that means the equipment identity register. Now let's see these terms in detail. So here the cellular subscriber station is there. So that means it is defined as the station in the cellular radio service which is used when the motion and the unspecified location. So cellular subscriber station, that means it is the movable, it can move from one place to another place. So that is the one type of the mobile station. Home location register, it is the permanent database about the subscriber in a large service area. So the home location register HLR is the permanent database. That database contains the subscriber location information. It contains whether the prepaid card is there or postpaid card is there, then roaming and restrictions informations, and supplementary services, whether it is any extra services. For example, you have the caller tune, so that is what the supplementary services are there. So any supplementary services are there in this activated in the mobile station, so that all the information is stored in the home location register. Then next one is the authentication center, a unit called the UCAC that provides the authentication and encryption parameters that verify that the user identify and ensure the confidentiality of each call. So the AC protects the network operator from the different types of the fraud that is found in this today's cellular world. Okay, you can see that more frauds are there because we have the more technology. Okay, so with the advantages that the same disadvantage also we have. So frauds are there, so we can detect based on this authentication center. Then next one is the visitor location register. This is also the one of the database. So temporary database which stores the customer information for each roaming subscriber visiting the coverage area of the particular MSC, that is the mobile switching center. It updates the whenever new mobile center enters in the area. By HLR database, it controls the mobile roaming in the area. Okay, so when in the MSC area, is there any new mobile station is there? So the new temporary number will be assigned to it. Okay. Now next is the base station. So a fixed station in the mobile radio system used for the radio communication with the mobile station. The stations are located at the center or in the edges of the coverage region, and they consist of the radio transmitter and the receiver antennas that is mounted on the tower. So that is known as the base station. That is the one type of fixed station is there. Now next one is the mobile switching center, that is MSC. So MSC is responsible for everything. So it coordinates the activities of the all the base stations, and it connects the entire cellular system to the PSTN, that is to the public switch telephone network. A typical MSC handles the 1 lakh cellular subscriber and the 5,000 simultaneous conversation at a time. Okay, so and accommodates all the billing system maintenance functions as well. So everything that is done by the MSC. So we can see MSC is we can say heart of the system. Okay, EIR, that is the equipment identity register. So it is a database that contains the record of all the cellular subscriber station that are allowed in the network, as well as the database of all the equipment that is banned. Okay, for example, because it is lost or stolen, etc. So the information that is stored in the EIR. Now let's learn the new topic, that is the CDMA forward channel. Okay, CDMA has a two type of channel, that is a forward channel and reverse channel. So forward link use the same frequency spectrum as the AMPS. For example, 869 to 894 megahertz. So one channel bandwidth is the 1.25 megahertz. Here the modulation scheme that is used, that is a quadrature phase shift keying, QPSK. So orthogonal Walsh chord are also used in this. Walsh chord, that is also known as the Hadamard chords, and they are used in the CDMA techniques. Forward channels are separated from each other using the different spreading codes. So different spreading codes are used to separate the forward channel. For example, 64 Walsh codes are used to identify the each channel. Okay, so different Walsh code are used to identify the different channels. Now here you can see this is the figure for the CDMA channel. So that is the forward channel. Okay, so here the one forward CDMA link is that. So 1.25 megahertz to the 869 to 894 megahertz band is there. And here the different types of channels are there. That is the pilot channel is there, synchronization channel is there. Okay, so numbers of channels are there, and for each and every channels we have the different Walsh code to define the channel. Okay, so here the fundamental channel is there, that mobile power control channel is there. Okay, so these are the different IS95, or you can say the CDMA channels are there. Okay. Now, which are the different types of the forward channel? So here you can see this is the pilot channel, synchronization channel, paging channel, and the traffic channel. So these four types of different channels are there in the CDMA forward channel. Now, what is the pilot channel? So it provides the phase for coherent demodulation time, signal strength, and comparisons with reference signals, or determining when to hand off or all the mobile stations. So it provides this type of information. So it is used to uniquely identify the sectors or cells. Sectors means that hexagonal cell that defined as a sectors. So it is the 4 to 6 decimals stronger than all other channels. So it is used to lock onto the other channel also. So it obtains all the zero Walsh code. For example, it contains the information except the radio frequency carrier. The next channel is the synchronization channel. So it is used to acquire the initial time synchronization. So synchronization measures includes the ID, that is means subscriber ID, network ID, the offset of the PN, that is a pseudo random number short code, and the paging channel data rate. Okay, so it broadcasts the synchronization message to the mobile station, and it operates at just 1200 bits per second. It also uses the Walsh code, that is 32, Walsh code 32 for spreading. Now next channel is the paging channel. Okay, so paging channel, these are the 7 paging channel used to page the mobile station in case of the incoming call, or to carry the control message for call setup, as we have learned in the GSM. When the mobile switching center identifies the device, at that time it does the paging. Okay, so for that paging it uses the paging channel. Okay, so it is the additionally scrambled by the PN long code, so which is generated by the LFSR, that is the linear feedback shift register, or the length is its length is 42. It operates at the rate of the 4.8 kbps and or the 9.6 kbps. Now next one is the traffic channel. Okay, so that there are total 55 traffic channels that is used to carry the actual information. It supports the variable data rates, that is the RS1, that is the 9.6, 4.8, 2.4 or 1.2 kbps. Here you can see the half rate is there. If the full rate 9.6 is there, the quality is best, and if the half rate is there, the quality will be reduced. And RS2 channel, that is the 14.4, 7.2, 3.6 and 1.8 kbps. RS1 is a mandatory for Interium Standard 95 for the CDMA, but support for the IS RS2 is optional. Okay, so if you are using the Interium Standard 95 CDMA, then it is mandatory that you have to use the RS1. It also carries the power control bits for the reverse channel. Now let's learn about the CDMA reverse channel. So CDMA reverse channel also use the frequency band of the 869 to 894 megahertz. Here the bandwidth of the each channel is 1.25 megahertz. So the reverse link is separated from forward link by 45 megahertz. So there is no spreading of the data symbol using the orthogonal codes. So instead of the orthogonal code, we use the waveform encoding. Okay, so spreading is carried out by 42-bit long PN, that is a pseudo-random codes. After spreading, they are further scrambled in the phase and the quadrature phase by PN spreading codes. Here the modulation scheme that is used, that is the orthogonal QPSK techniques. Now here you can see this is the figure for the CDMA reverse channel. Okay, so this CDMA link is the reverse link is that here 1.25 megahertz to 824 to 849 megahertz band is there. Here access channel is there and the traffic channel is there. So it is the Interium Standard 95 CDMA reverse channel. Now the reverse channel has two types. So basically there are two types in the reverse channel, access channel and the reverse traffic channel. So let's learn by it. Now first is the access channel. Now what is the meaning of the access channel? So it is the random access channel with each channel uniquely identified by their long codes. So there are 32 access channel per reverse channel. So work at the fixed data rates of the 4800 bits per second. So it allows the mobile to communicate with the system for registration, call origination. So when call origination is there, this access channel is used. That means when the mobile station is doing the calling, so at that time this access channel will be used for transmitting the information. Reverse traffic channel, it carries the traffics from the mobile station to the base station. So it operates on the variable data rates. Now next is which are the features of the CDMA. Okay, so in CDMA every channel uses the full available spectrum. Individual conversations are encoded with the pseudo-random digital sequence, okay, and then transmitted using the wide frequency range, as we have learned in the direct sequence spread spectrum. Okay, so in spread spectrum we have learned that the signals are spreading. Okay, so individual conversions can be encoded using that spreaded code. CDMA consistently provides the better capacity for the voice data communication, allowing more subscribers to connect at any given time. CDMA is a common platform on which the 3G technologies are built. So 3G is built on the CDMA. Many users of the CDMA system share the same frequency, either TDD or FDD. TDD, that means time division duplex, and FDD, that means frequency division duplex, that may be used in the CDMA. Now next feature is what, unlike the TDMA or FDMA, that is the time division multiple access or the frequency division multiple access, CDMA, that is the code division multiple access, has the soft capacity limit. So it means it increasing the number of users in the CDMA system, it raises noise floor in the linear manner. Okay, so thus there is no absolute limit on the numbers of the user that are adding in the CDMA, but the performance degrades gradually. If you are adding the numbers of users, the performance will be degraded. CDMA is an interference limited system. Then next feature is what, the multipath fading is substantially reduced because the signal is spread over the large spectrum. That's why. So if the spread spectrum bandwidth is greater than the coherence bandwidth of the channel, the inherent diversity will reduce the effect of the small scale fading. Now here the channel data rates are very high in CDMA. So the symbol duration is very short and usually much less than the channel delay spread is there. And here the rake receiver can be used to improve the receptions by collecting the time delayed and the versions of the required signal. So rake receiver will be used at the receiver side to stop this time delay that is occurred in the signal. CDMA uses the co-channel cells, thus it can use the macroscopic spatial diversity to provide the soft handoff. Okay, so it use the co-channel cells that use the macroscopic spatial diversity. Now next topic is the CDMA 2000 architecture. So here you can see we have learned about the CDMA architecture, that is the Interium Standard 95 architecture. Here this is Interium Standard 2000 architecture. Okay, the concept is normally same in the both the network, both the architecture. Here the BTS is there. BTS will send the signal to the BSC that you can see. Base stations survey base station controller is there, and it will send the signal to the IP router. Okay, that is we can say it will work like the MSC, that is the mobile switching center, and it is connected with this through three different that component, that is AAA is there, PDSN is there, and home agent is there. Okay, that is connected with these three different components, and after that IP firewall is there. This IP firewall is responsible for any unauthorized access, that attack is there of the virus. So for that we have the IP firewall is there, and after that IP router is there. Okay, so this router is responsible for transmitting the informations to the internet, to the any private data network, that we can say that to the PDN network. And if any data will come from the different internet, different network, then this router will send to the firewall. Firewall pass this. If no virus is there and if no unauthorized access is there, then it will pass that data in the network. Okay, so the rest of the thing that is same as in the CDMA standard. Now, what is the terms that you can see? That AAA, that means what? The authentication, authorization, and the accounting. Okay, so the authentication, authorization, and accounting will be performed by that AAA. Then PDSN is that is the packet data servicing node is that. So it is responsible for transmitting the packet data. BTS, that all of you aware about this. BTS, that means the base transceiver system, and BSC, that means the base station controller is there. Okay, so in this video we have learned that the CDMA architecture, that is also known as the Interium Standard 95 architecture. So if in exam it will ask, you can write the same Interium Standard 95 or the CDMA architecture. Then we have learned about the CDMA forward channel and CDMA reverse channel. Okay, and the features of the CDMA, and then we have learned about the CDMA 2000 architecture. So thank you for watching. Remaining interesting topic we will cover in the next lecture. Thank you.